Alright, okay, this is another example for parametric differentiation. So we have x2 cos 2 theta and y equals to 2 theta plus sine 2 theta. So show that the dy dx is negative cot theta. So as you know that this will be your parameter, right? Theta and theta. So which is can relate x and y. So the theta is your parameter. So as you know that to find dy dx, right? So dy dx is dy dt. As usual, we are using t to represent parameter, dt over dx, right? But for these cases, your parameter is theta, right? So you're going to replace the t with theta and the t here with theta. So means that we're going to find dx d theta, okay? Dx d theta. And we're going to find dy d theta. So dx d theta, differentiate cos. Cos, you have negative sine 2 theta, right? Yes or no? Differentiate cos, you have negative sine 2 theta. But don't forget to differentiate the function inside here. Differentiate 2 theta, you will have 2, right? Negative 2 sine theta. So as same thing, you dy d theta, differentiate y with respect to the parameter theta. So differentiate 2 theta, 2. Differentiate sine, easily you know this is cos, right? Cos 2 theta. Sine, differentiate, you're getting cos. Differentiate 2 theta, you have 2. So you have 2 plus 2 cos 2 theta. So now you need to know how to apply the chain rule, right? The chain rule. So your dy dx is the same as dy d theta, right? Dy d theta, which is 2 plus 2 cos 2 theta, multiply with d theta dx. D theta dx. This is dx d theta. So reverse this order, then you are getting 1 over negative 2 sine 2 theta, right? Negative 2 sine 2 theta. So if you look at this, if you multiply, you are getting, okay, you can factor out the 2, easy for you. Factor out the 2, you will have 1 plus cos 2 theta, multiply with, means that 1 over means divided by negative 2 sine 2 theta, right? So as this 2, so you are getting negative, right? 2, 2, 1. So negative 1 plus cosine 2 theta over with sine 2 theta. You have already applied the parametric differentiation, right? And you're getting this one. But the question requires to show that dy dx is negative cotangent theta, which is very different, right? Very different from this. But you have to believe that this will become this. Yes, not by using some trigonometric knowledge. So it means that this question involving that you need to have the knowledge of trigonometric, right? So you have to have a knowledge of trigonometric where you have to simplify this to getting negative cotangent theta here. So okay, now I'm showing you how to getting negative cotangent theta. Alright, okay. As you see that the final form of after you simplify, you are getting, you believe that you are getting this, right? As you see, this is a theta, this is a 2 theta. So we're going to apply the double angle formula. As you know that sine 2 theta, the double angle formula will be 2 sine theta cos theta, and cosine 2 theta, you have 3 formula. As you know, you have cos square theta minus sine square theta. You have 2 cos square theta minus 1, and you have 1 minus 2 sine square theta, right? You have all these formula. So it's up to you to using which one is the most effective to simplify from here to here. So as I see the product there, this is a negative cotangent theta is a ratio of cos over sine, right? Cos over sine. So it means that for the cos 2 theta, I have to choosing a formula that relate only cos theta. So I will choosing the second formula, the second formula. So I believe that this is work for me. So negative 1 plus and cos 2 theta, I will replace by 2 cos square minus 1. 2 cos square theta minus 1 over with sine 2 theta. Okay, sine 2 theta is 2 sine theta cos theta, right? 2 sine theta cos theta. Okay, now I have to simplify 1 minus 1. 1 minus 1 is 0, right? 0. So 0, negative 2 cos square theta. This one cancel out. You have negative 2 cos square theta divided by 2 sine theta cos theta. As you know that the 2 and the 2 cancel off. So you have negative cos square over cos. Cos square theta over cos. So you will still have remaining 1 cos theta. So you are getting negative cos theta over with sine theta. So finally you have shown that this to be negative cos over sine, which will be negative cotangent theta, right? So you have shown that dy dx is negative cotangent theta by using parametric differentiation. Okay, let's see part B, how to solve, how to finding the value of theta.